simple stretching the storage network. Option 1B is enhance that by doing a storage vMotion before vMotion. We did a lot of testing about, how long does it take, what happens over distance. And then there's these advanced storage options, right? So advanced active multi-array models, and you'll see that in the diagram. And then there's the other model, which is over much shorter distances, you can actually stretch a single array. So a single array that spans sites. So it probably helps to visualize this. So here's one thing, and this was an example in one test, where basically you literally are doing a simple extension and you have two totally different storage arrays. They're presenting VMFS volumes or NFS data stores across both possible sites, right? This reduces the number of data stores that you can have by half on any one side, because literally half the data stores are being owned by one and the other half are owned by the other. And you literally simply do a vMotion between two separate clusters, which we're going to talk about later on, but the storage doesn't move, right? Advantage, fast, simple, easy. Disadvantage is that the storage is still originally at the original target size, so it wouldn't solve the disaster avoidance problem or the maintenance for the whole data center problem. The other option, again, which is basic, you could do this with any storage, you do it with all the stuff out of the box, is storage vMotion before vMotion. One thing that you guys will see, and I think it's kind of cool, is that this is all out of the box. You could literally be doing this tomorrow. So the question is, how well does it work? How well does it work over distance? It goes like this. First, you do a storage vMotion. The VM decays, all the VMX files move over to the other side. Lots of storage vMotion improvements in vSphere, so performance is much faster. The atomicity of the operation is much better, and now it has a GUI too. And then you vMotion after the fact. Here, everything now gets over to the other side. It's going to take some time, and we'll show you the data that we got from the testing. Option 2 is this advanced active model. So if you think about this, and you think about the requirements that we talked about earlier, it's got to have some sort of n-node scaling model, because it's going to have to scale up to whatever the performance model was before. You can't degrade the performance by adding this technology, right? You'll notice that here I've drawn two different arrays. So the idea here is that this could work in heterogeneous use cases. And what's interesting is that you see how it says VMFS active and then VMFS active prime. It's kind of probably should have made them in different colors or something. There's a tiny little right beside it. But basically the core idea here is that each one of the vSphere clusters is looking at a VMFS data store that looks like it's the same, but the data actually exists in two different places. So there's a copy at one side and there's a copy at the other side. And basically, in this case, you literally just do a vMotion, and because it uses that single writer model, at the moment of the vMotion cutover, the I/O is no longer going to VMFS active, it's now going to VMFS active prime, meaning it's actually now sitting on the blocks are actually stored on the array that's in the secondary site here. Make sense? This is a bit of a mind bender, but very, very cool technology. And the other option, which is something that we can do over much shorter distances, is the way that we design the VMAX is that it's got a virtual matrix model, which means that VMAX has got this idea where all of the memory of all the nodes is shared, right? So it's one giant memory pool, and they're interconnected via very, very high speed, extremely low latency links. So if you actually go to the booth and and open the box and you take a look behind it, you'll see basically these cables that link it together into one giant memory address space. So even though it looks like there's two arrays in this picture, it's actually really just one, right? They're operating as one site that's been stretched, but you'll notice the distances are much, much, much smaller. This is something that currently today, if you ask EMC, we currently would say you cannot, this is not supported, so this is a future, right? But this is something that we know technically that we absolutely can do. It's a matter of calling in, updating the final support statement. So the key thing here is there's really only one array, only one data stored. Now that we construct it so that the data is stored at both sides, so if there's a massive catastrophic loss at one site, there's no data loss in that case. And in this case also, it's just a simple vMotion. There's no storage vMotion step. So